Hello everyone, this is Sangram Kakade from Aryan College of Arts, Commerce and Science. Now in today's lecture, we will see the rest of the points which have been remaining from the first chapter, that is Introduction to C Language. But we will do the quick recap. In last lecture, we have seen the brief history of C programming language. We have seen few features of C programming language, and we have seen the basic structure of the C programming language. Now let us continue with the basic structure of C programming language. Can define them in this section. Either you can define here or you can declare and define in the global declaration or the function declaration as well. Now let's see the structure, basic structure of the C. Here we have taken an example which describes all these sections. Now here in document section, what we have mentioned or what we can mention is the name of the program. You can add whatever things you may want, like timestamp, and you can elaborate what the program is doing exactly. If the program is doing addition of float value, you can mention that it is doing addition of float value, or you can say suppose if the program is calculating the salary, net salary, then you can mention in the document section that the program is being returned to calculate the net salary of your employee, right? So you can put these things in the document section. Next is preprocessor directives. Now here you have to mention the preprocessor directives or include the preprocessor directives which are necessary in your program. So here we have included two directives, that is preprocessor directives. One is standard input output and the console input output. Now we have included standard input output because we need to use certain functionality which has been returned in standard input output. Like here we have used printf function. Now it won't be we won't be able to use the printf function if we wouldn't have included this preprocessor tag, because printf function is returned in standard io.h header file. So whenever you want to use any functionality has been returned in any other library, you must include that library or the directive you put, and then you can use the functionality which has been returned in directives. Then comes the definition section. Here you can define any variable or any function. Declare any function. Okay. Here we have used max variable and we have initialized those that max variable, and we have given the value 100. Next, here there is a global declaration section. Here we have declared one method, that is add. This is a just declaration. This is how we declare the method, and we have provided the definition here in this next part in the function definition section. So here just the declaration, and we have declared the global variable x, which is of type integer, and we have assigned the value to x, that is 100. Now this is also an variable. This can be also treated as a variable, and this can be also treated as a variable. Main difference between two is this is macro. It will be treated as a macro, and once the value is assigned, we won't be able to change this value throughout our program. But the thing is different with the global declaration x, because this value can be manipulated and changed during the execution cycle of the program. That is the basic difference. Next comes the very important part, that is main function. This is how we are going to write the main function. Int, you can skip this integer part, but in few programs or in few books they have referred to mention the integer part. So this is int main and opening closing bracket. This suggests that this is a main function. Now this is an entry point your every program, C program. So this main function is followed by body of the function. A body of the function is bounded by opening curly bracket and closing curly bracket. Between these brackets, if again it is divided into two parts. Basically, it is an declaration part. First comes the declaration part, and second comes the executable part or the body of the function. So in the declaration part, you can declare as much as variable that you are needed to do your function properly. And in the main function or executable part, you can write the expressions or the statement which actually carry out your processing part of it. Last but not the least is function definition or user defined function section. Suppose, as I have said, is a structured programming language. So the structured programming language, what I literally mean to say is it follows a specific structure. Whenever we are dealing with any complex problem, we basically break it down into a smaller, simple problem. So suppose I want to make a calculator. Now, if I write down the code, entire code with main function, it will be very much complicated. Instead, I'll break down this task into an several small tasks. Like for in addition, I'll write the separate function, user defined function. For the subtraction, I might write the defined function and so on. So I'll write the function to each and every operations on the calculator, and later from the main function from here I can call my function which I have you know, used to do the several operations. So this is it about the basic structure of this program. I hope you have understood. Uh, at the time being, we will, we are going to see the programming part. I'll explain in more detail when it comes to. Now let's see the compilation process. Writing a program is not everything until you won't compile it and won't run it. So after writing any program, you need to do two basic things. That is, you need to compile the program first, and then you need to run the program. Now the compilation is a process of converting your source code into an object. Now, object code is a code which can be understood by your hardware of the computer, and it executes that object code and returns you the result. It is done with the help of the compiler. The compiler checks the source code for the syntactical or structural error, and if you have any syntactical error or structural error, it will stop and it will flash you with the message of that specific error. Later you can resolve that error and you can again compile the program. And if the source code is error free, then it generates an object code. But it is not as simple as it sounds. Compilation is a process, and during this process your code goes through a lot of changes. It doesn't directly convert into an object code. So let's see that process step by step. The following are the phases through which your program passes before being transformed into an executable form. After the compilation, you get a code which is actually an executable form of your program, and then later on you can execute that code. So the first phase is preprocessor. In the preprocessor, what actually happens is, suppose you have write a code. Let's see it call as a source code because it is a meaningful term to call it. The source code is a code which is written in the text editor, and the source code file is given an extension. So whenever you are writing the program, you are going to save that program with an .c extension, and that program will be called as a source. This source code is first passed to the processor. We are going to pass this code to the preprocessor. We don't have to pass it while compilation. While we are compiling the program, it is automatically passed to first. It is passed to the preprocessor, and then the preprocessor expands this code. Now, when I say expansion, means it expands or it includes the code which has been returned in the header file. So here the studio.h, that is standard io.h dot header file, that is the header file, some code is returned into that header file. So what preprocessor does is preprocessor will include that code into your program. Next thing is compile. The code which is expanded by the preprocessor is passed to the compiler. Later, the compiler converts this code into an assembly code. Or we can say that the compiler converts the preprocessed code into an assembly code. So it takes input from the preprocessor and it gives the output in the form of an assembly code. Next is assembler, which handles the assembly code. The assembly code is converted into an object code by using an assembler. The name of the object file generated by the assembler is the same as the source file. The extension of the file in DOS is .obj, and in Unix the extension is O. If the name of the file, that is source file, is say suppose hello.c, then the name of the object file will be hello.object. So assemblers takes the code which has been outputted by the compiler. That means it takes the assembly code from the compiler and it produces the object code for further processing. Next phase to which the program goes is linker. Now assembler have given us the object code. Now what happens with the object code? Mainly all the programs written in C uses library functions. Like we have used printf, which is a library function which has been mentioned in the standard io.header file. These library functions are precompiled and the object code of these library file is stored with .lit or a extension. This main working of the linker is to combine the object code of library files with the object code of our program. Sometimes the situation arises when our program refers to the function defined in other files, and the linker here will play a very crucial role. It links the object code of the file to our program. Therefore, we conclude that the job of the linker is to link the object code of our program with object code of the library files or the other files. The output of the linker is executable file. The name of the executable file in the Windows or DOS is .exe and in Unix it is a.out. For example, if we are using printf function in the program, the linker adds its associated object code in an output file. So that is the job of the linker. As I have said, it links the library file object code to our object code, that is our program's object. This is the diagrammatic expression or the explanation for the phases and what exactly happens to your code. It shows that the source code go to the preprocessor expands the code, and then the expanded code is sent to the compiler. Then compiler assemble, generates the assembly code. Then assembly code is passed to the assembler. It creates an object code. Then the linker, then the linker links your object code with other files object code if necessary. If necessary, it is not compulsory. If necessary, if you have used a function from any other file, then it will definitely do it. And then later, lastly, it will create the executable code. Now you are in the position to execute. Let's understand through the simple example. Let's take the example hello.c. Now here I have included standard IO reader file int main, and I am simply printing hello Arihan, right? So when I start the compilation, hello.c, that is our source program, that is C program, is passed through the preprocessor. Now preprocessor will expand the code, and it includes the standard IO dot header file, entire code into the program. Now the output of the preprocessor code is hello.i. Now hello.i is expanded code which has been generated by the preprocessor. Now this expanded code sent to the compiler. Now compiler compiles that code, and if it is error free, then it converts, or it gives the assembly code. The extension of the assembly code is S. It will give you hello.s. Then this assembly code, that is hello.s, will be passed in the assembler. Now assembler will convert this assembly code into an ultimate object code. This object code again is passed to the linker, and it linker will link the object code of other file, that is here standard io.h. The code object code will be taken, and it will be linked to our object code. So here basically we are using printf function from the standard io.header. It will take the printf codes, right, object code, and it will link, or it will put here entirely. Then linker will give us an executable hello file. Then here I have specifically mentioned the loader, because loader is necessary to load your executable file into the RAM, right? So whenever you have to run any program, it must be residing in the RAM. So it will load the file into the RAM, and once you start execution, it will give you the output. So that is the basic compilation process of the C program. Now we'll move towards the conclusion of today's video lecture. In today's video lecture, we have discussed history of C programming language. Later, we have seen several features which are associated with C programming language. Next, we have seen basic structure that we need to follow while writing the C program. And lastly, we have seen the compilation process or in C for your C program. I hope you have liked this lecture. Stay home, stay safe, and thank you.